Greetings everyone. I am RUKESH.A.R. Along with me is Mr. D. KIRUBANANDAN. We both are pursuing our final year civil engineering at Weldtech High-Tech Dr. Rangarajan Dr. Shakuntala Engineering College. I am here today to explain to you people about my research and experimental study on the behavior of concrete by addition of bamboo as fiber and comparing it with the conventional concrete. We had done this project at RUKESH.A.R Temple Green, Mathur site, Oragadam, Sriperumbudur, Chennai. We had done this project under the guidance of Ms. R. Aishwarya, Assistant Professor, Department of Civil Engineering, Weldtech High-Tech Dr. Rangarajan Dr. Shakuntala Engineering College, and also along with Mr. A. Kandaswamy, Assistant General Manager, RUKESH.A.R Temple Green. Bamboo is a natural perennial grass-like composite. There are about 1250 species identified throughout the world. The advantage of using bamboo is that it reaches its full growth in just a few months. But here nowadays bamboo is used as an external material for construction purposes, like it's being used for scaffoldings and housing. But our idea here is to use the bamboo for an internal purposes, like mixing it with the concrete to increase its strength. We had used different mixing ratios of bamboo fibers such as 1%, 2% and 3%. Objective of our study is to find out the strength test results and comparing it with the nominal mixed concrete and fiber mixed concrete with different mixing ratios. These are the materials which we had used for concrete. Cement of 53 grade, JP branded. Fine aggregate of from river sand, which is free of moisture, and then 20 mm coarse aggregate, and then water complying with the pH level, and then bamboo as fibers. This is the literature review of Harish and Vamsi Krishna in 2012 on the topic investigational properties of bamboo as reinforcing material concrete. They found out the various physical and mechanical properties of bamboo for using as reinforcement in concrete. He concluded that the strength of the bamboo is about 125 Newton per mm square. This is the journal by Liu and Ziog on the title Study on the Mechanical Properties of the Bamboo Fiber Reinforced Cement Composite Materials. They cut the bamboo into 10 mm, 15 mm and 20 mm length fibers and mixed it with concrete. He casted the cubes and put it to compressive strength test. They pre-treated it, and then they concluded by saying that there is an increase in the rupture strength because of the pre-treatment done to the bamboo. This is another journal on the title Performance Evaluation of Bamboo Twig as Potential Reinforcement in Concrete Considering Tensile Property by Mohammad Hassan Sabir in 2012. The study presented the use of bamboo twig as reinforcement in concrete. The tensile strength test of bamboo twig specimen having 3 notches was performed. The stress-strain relationship of bamboo twig specimen is observed linear till failure load, and the modulus of elasticity of bamboo twig is lower than the steel reinforcement. He later concluded that the knot was found to be the weak point of bamboo, which needs an enhancement. This is another journal on the title Durability Analysis of Bamboo as Concrete Reinforcement by Lima in 2008. Analysis investigated the durability of bamboo used for concrete reinforcement. He found out that the average bamboo tensile strength was found to be 280 megapascals without node and 100 megapascals with. This is another journal on the title Durability Analysis of Bamboo as Concrete Reinforcement by Mr. Lima and all. The experimental test on bamboo species showed that on the bamboo species Dendroclaus showed that the bamboo tensile strength is comparable with the best woods, which means he's trying to say that the bamboo fiber of that species was greater than many other strong trees like oak tree and all. Then he wanted to find the durability of those bamboo fiber of that bamboo. So what he did was he put the bamboo into 60 cycles of wetting and drying, and then he found out that there was no decrease in the bamboo tensile strength, neither the Young's modulus. These are the benefits of bamboo: durability, affordability, strength, and rate of growth. These are the properties of bamboo. Specific gravity was found to be 0.575 to 0.655, and the modulus of elasticity was found to be 1.5 into 10 power 5 kg per centimeter square to 2 into 10 power 5 kg per centimeter square. The bond stress was found to be 5.6 kg per. This is our methodology for doing this experimental study. We had first collected the resources, and then we had studied the materials. We had casted cubes and cylinders with nominal mix and the fiber mixed concrete, and then we put those specimens for compression strength test and split tensile strength test, and then we compared the results of nominal mixed concrete and fiber mixed concrete, and then we came to a conclusion and we had done the report. This is how we had processed the bamboo. The bamboo was cut into small pieces of around 30 centimeter height, and then we had taken we had put the bamboos into fibers manually by the usage of. We had taken around 10 to 15 bamboo fibers which we had done manually, and we had found that the length of those fibers was found to be around 100 mm, and the diameter of the fiber was found to be 0.75 mm. Thus the aspect ratio was 133.33. Then we had done the study on those materials. We had done sieve analysis for coarse and fine aggregate with the usage of these sieves which you are looking at, and also we had done specific gravity test on coarse aggregate and fine aggregate. This is the tabulation for sieve analysis on 20 mm aggregate as per IS 460 in the year 1962. We had put the 20 mm aggregate into various sieves of sizes ranging from 4.40 mm to 4.75 mm, and they had all complied with the specification limit as per IS 460 1962. And also we had done sieve analysis for fine aggregate with the sieves ranging from 10 mm up to 150 mm microns, and they had also complied with the specification limit of IS 460 year 1962. This is the specific gravity test on 20 mm aggregate, and the average specific gravity was found to be 2.6. Specific gravity test on fine aggregate was done, and then the results were tabulated as shown, and then the average specific gravity of fine aggregate was found to be 2.6. The formula which we had used for finding out the specific gravity. Now we had come to the design procedure, that is M25 mixed design. Based on the materials which we have and the specific gravity and the other properties of the materials which we had done the design procedure to find out the mixed proportions. The degree of workability is 0.9. The degree of quality control was good, and moderate exposure was there, and the specific gravity of cement was 3.15. The specific gravity of fine aggregate and coarse aggregate were inferred from the previous test which we had done, and the values were taken as 2.62 and 2.67 respectively. The grade of cement, as I said, is 53 grade. The target mean strength was found to be 31.6 Newton per mm square. The water cement ratio we had taken as 0.45, which is lesser than 0.6. Now we had come to the determination of cement content. We had determined the cement content from the water content and the water cement ratio, and the value of cement content was found to be 403.33 kg per meter. Previous value of coarse aggregate and fine aggregate from the table 4 IS 1026 to 1982, E was 0.64 and 0. So we had put that here, and we had found out the volume of coarse aggregate was 1166.768 kg per meter cube, and the volume of fine aggregate was 644.07 kg per meter. Now we had come to the final part of our design procedure, that is the mixed proportion was successfully found out, and the proportion was 1 part of cement with 1.5 parts of fine aggregate with 2.9 parts of coarse aggregate along with 0.45 parts of water. As you can see, we had used mixer for mixing of fiber concrete. Cubes were casted and cylinders were also casted. We had put the cubes for compression strength test, and as you can see, the pattern of failure was pattern of failure is here in this picture, where these are the tabulation results on compressive strength test on nominal mixed cubes. That is without any fibers. We had used only the coarse aggregate, fine aggregate, water and cement, and the strength that after 28 days of curing was found to be 29.54 Newton per mm. This is the tabulation results with 1% fiber mixed concrete. That is, we had mixed 1% of the cement content as bamboo fibers in the concrete mix, and after 28 days of curing, the strength was found to be approximately 33, which is higher than the previous result. And this is the compression test results on 3% fiber mixed concrete, and the value has decreased after 28 days of curing to 16 Newton per mm. This is the comparison tabulation. As you can see, with the fiber content, with 0% fiber content, the strength of the concrete was 29.54, and with 1% addition of fiber content, the value has increased from 29.54 to 32.59, and there was a nominal decrease with 2% addition of bamboo fibers, and there was a drastic decrease in the compression strength with 3% addition of bamboo fiber. As you can see, in the graph, there is an initial increase, and then there is a drastic increase, which means there is an increase with 1% of bamboo fiber, and then there are gradual decrease for 2% and 3% addition of bamboo fibers. And then we had also casted cylinders. We had put those cylinder specimens to compression strength test, and as you can see, with 0% fiber content, that is with the nominal mixed concrete, the compressive strength was found to be 16.98, and with 1% of addition of bamboo fiber, it has increased drastically to 28.3 Newton per mm square. And then, as usual, there is a gradual decrease with the increase in the fiber content. With 2% addition, the compressive strength was found to be 15.56 after 20 days of curing, and with 3% addition of bamboo fiber, the compression strength had decreased to 14.15 Newton. This is the formula which we had used for finding out the compressive strength, and this is the comparison of cylinder compression strength test results. As you can see, with the increase of 1% of fiber content, there is a Himalayan increase in the compressive strength of the cylinders after 20 days of curing. It has increased from 16.98 to 28.3, and then with the increase in the fiber content, there is a decrease in the compressive strength. As you can see, there is with the first increase, as you can see, there is a great jump from 0% of fiber content to 1% of fiber content, which means there is a huge increase in the compressive strength of cylinder specimen with 1% addition of bamboo fiber, and then there is a gradual decrease with along with 2% and 3% of fiber content. Then we had also done split tensile strength on cylinder specimens. With the nominal split tensile strength with nominal mix was found to be 2.68 Newton per mm square, and with 1% addition of bamboo fiber, the tensile strength had increased from 2.68 to 3.11 Newton per mm square, and then it had also slightly decreased with 2% addition of bamboo fiber to 2.41 Newton per mm square. The tensile strength had decreased to 2.12 Newton per mm square with 3% addition of bamboo fiber. This is the formula which we had used for finding out the tensile strength. TSP, which is the tensile strength, is equal to 2 times the load at failure divided by the diameter of the cylinder into length of the cylinder into pi. This is the pictorial representation of split tensile strength test results. As you can see, there is a slight increase with 1% of fiber content, and then there is a gradual decrease with increase of fiber content. Hence, we had come to the conclusions of our experimental study. I'd like to conclude by saying that this cube compression strength increases by nearly 10 to 15 percentage with 1% addition of bamboo fibers, and it has found to decrease by approximately 7 to 9 Newton per mm square for 2% addition of bamboo fibers, and it has also decreased drastically by 12 Newton per mm square to 15 Newton per mm square for 3% addition of bamboo fibers. The cylinder compressive strength had increased by 12 Newton per mm square with 1% addition of bamboo fibers, and the cylinder compressive strength is found to decrease for 2% and 3% respectively. The cylinder split tensile strength increases by 15% for 1% addition of bamboo fibers, and as usual with the remaining addition of fiber, there is a decreased value of split tensile strength. Thus, I'd like to say that the 1% addition of bamboo fiber has shown a positive trend. It is evident from the previous charts and the previous graph that the addition of 1% of bamboo fiber had increased the strength of the concrete. Hence, our experimental study has paved a path for an exclusive study of bamboo as fiber in the concrete technology. Thank you all. Have a good day, and thanks for your patient listening. Have a good day. Bye.